Hello Year 5, happy Friday, welcome to today's maths lesson. Now, today we are starting a brand new unit looking at fractions, and today we are focusing on fractions and equivalent fractions, and I am super excited because I know what budding mathematicians we have in our year group, and I think you're really going to enjoy the next few weeks as we explore them. Now, to start us off, like normal, here is your arithmetic starter. Have a go. My top tip for number 5 would be make sure you keep each number to its own square. Keep them in the row. Make sure you don't get yourself muddled up and give yourself plenty of space to work it out. Okay. All right, I hope you have 5 answers. If you don't, then pause me again. Quick, have another turn. And we'll have a look at these answers here. Do they match up to yours? If they do, give yourself a big pat on the back. If you don't, have a look at the ones you got wrong. See if you can work out your marvellous mistake. Any questions, pop me an email. All right, guys, let's go on to the next one. Okay, here is your opening challenge. Can you sort these cards into different groups? Now, top tip, there is more than one way to sort them. You could sort them into 2 groups or more than that if you would like to. And there are lots of different ways to do it. But you've got to be able to explain why you've grouped them the way you have. Have a go, pause me, and then I will show you how I've grouped them today. Okay, let's have a look at how I grouped them. Here we go. I've used stars because I do like a star. And I've grouped them into purple and blue. And the way I decided to do it was I looked at all of these representations and I thought, oh, well, here I've got 5 things overall, and I've got 3 coloured in. So that means 3 out of 5 are coloured in. And I had the same here. I've got 5 counters, and 3 of them are red. And so I thought, oh, that's 3 red counters out of 5 overall. And here I'm going to call it a chocolate bar. I've got a chocolate bar here, and 3 lines of the chocolate bar are left, and 2 have been eaten. So overall, I've got 3 lines of chocolate left out of 5 lines of chocolate. And I think all of those remind me of 3/5 or 3 over 5, a fraction of 3 over 5. That's why I decided to match those ones up. Then I had a look at these ones here, and I thought, oh, well here I've got 4 sections, and I've got 3 yellow sections overall. So I've got 3 yellow sections out of 4. Now here I've got some pneumacon, and now I've got 2 different slabs of pneumacon if I had them in my hand. However, this one here covers up the whole. So here I've got 4 layers of pneumacon and 3 layers on top. So 3 out of the 4 altogether. And then I've got my 3/4, 3 over 4 up here as well. And that's why I decided to put those together. Oh, and I've missed one. I've got here as well. This is the 3rd out of the 4 lines, so it's 3 out of 4. And that's why I decided to group them that way. You might have had it a completely different way. You might have gone, right, well here I've got 2 whites and 3 reds, so that's 2 out of 5. And the same with your counter, so you might have gone 2 yellows out of 5 counters all together. There are lots of different ways you could have grouped these. But I wonder if you can work out why I've got all these different representations and we're looking at fractions. Well, let's have a little refresher as to what a fraction actually is. Here is a fraction. It's 3 over 4, also known as 3/4. Have a look. Do you know what each part of the fraction is called? Now, the top of the fraction, above our line, is called a numerator. And that stands for how many equal parts do you have? How many parts do you physically have? Okay, and the bottom is called a denominator. And that stands for how many equal parts would you have if you had the whole? Because a fraction is less than a whole. So a fraction, as long as it's not top heavy, which we'll get into next week, is less than a whole. So here, the whole would be 4 parts, and that would make up 1. But I've only got 3 of them. So I've got 3 out of the 4 parts needed to make a whole. And you can see I've represented it here using a bar model. I've got 4 parts here, but I've only got 3 of them shaded in, so I actually only have 3 out of the whole 4 parts. Now the way I remember which way round it goes is that denominator reminds me a little bit of a denominator. A demon would be down below. That's where Thanatos was anyway. So we've got our numerator on top and our denominator on the bottom. Okay, so now the next question is, how can fractions be equivalent? And what does equivalent mean? Well, you can see I've pulled it out here. Equivalent means equal to, the same as, or identical. So how can 2 different looking fractions mean the same thing? Well, what I'd like you to do is to find 2 pieces of paper, and then I will show you. Okay, here are your instructions. You can do it along with me. If you need to catch up, you can do it and have me on pause. But I've got 2 pieces of paper. I've got one here, and I'm going to fold one piece into 2 equal pieces. I'm going to fold it in half, just like that. I'm going to pop that down in front of me. And then my other piece of paper I've got here, I'm going to fold it into 8 equal parts. I'm going to fold it in half, and in half again. So I'm going to fold it in half 3 times, and that should give me 8 equal parts. Now what I've done is I've done a little Blue Peter trick, and I've coloured it in so you can see it better on the screen. And now you should be able to see that I've got 2 pieces of paper. One has 1 line down the middle because it's in 2 parts, and one has lots of lines because it's in 8 parts. Okay, now I do have this on the screen as well to look at, so I can put my hands down. Once you've got yours in front of you, the same as I have, let's have a look at them. Okay, now you can see that I have folded this piece of paper in half and coloured in 1 half, and this part has been put into 8 parts, but I've also coloured in the same amount on both pieces of paper. Now, the pieces of paper are exactly the same size, so they're the same whole overall. They are all, the whole is equivalent to 1. But here, 1 over 2 is the same as 4 out of 8. It looks exactly the same because it is the same. It's just being represented by different numbers. Okay, can you find any other equivalent fractions using a piece of paper? How could you do it? I'd love to hear or see some of your findings out. When you're ready, move on with us to the next bit. Okay, this is a fraction wall. Now, on the website is a copy of the fraction wall for you guys to have. I recommend having a copy printed off or having it on the screen near you when you are doing fractions with us over the next few weeks, because it's a really useful tool to use. I'm going to show you how we use it. Let me get a line ready. So this at the top is equivalent to 1 whole. And actually, all of these, each line is equivalent to a whole. Okay? And I can tell that because I've got 12 down here. 12 12s make up 1 whole. Now, if I do this and I put a straight line all the way down my fraction wall, I can start to see some equivalent fractions. Now, they're equivalent if it has the exact right number inside 1 half. So here I've got 1 half. This is equal to 1 half. I know that because I halved my fraction wall. Now, 1 half is the same as 2 quarters because 2 quarters fit perfectly onto that half. Okay? 1 half is also the same as 3 sixes because I've got 3 sixes on this half. Can you spot a pattern yet? 1 half is equivalent to 1, 2, 3, 4 eighths. Again, because it fits into 1 half of my fraction wall. And so on and so on. What have you spotted out of my fraction wall there? Have you spotted that all of the equal numbers, all of the equal numbered denominators, manage to fit themselves equally into a half? Have an explore with your fraction wall as well. What other common equivalent fractions can you find? Okay, so how can we use our multiplication and division knowledge to help us find equivalent fractions? Now, we've been doing lots of work on multiplication and division, so this should be pretty simple for us to get our heads around, I think. Okay, so here I have a piece of paper folded into 4 and a piece of paper folded into 16. And I've shaded the same amount each time. What multiplication do you think we could do to represent what has happened? Okay, so you can see my explanation here. I've got it. I'm going to do it down here as well. How did we turn 1 into 4 using multiplication? What did we times it by? We times it by 4. Nice and simple. 1 times 4 is equal to 4. Easy peasy. But it's an equivalent fraction that we're working with. So what do we also need to do to our denominator? We need to do 4 times 4, or 4 squared, if you will. 4 times 4, which is equal to 16. And that is what we've done. Okay? Have a go at using this method to find equivalent fractions to 2 over 4, 3 over 4, and 4 over 4, where the denominator is 16. What do you need to do to that top number? If the denominator goes from 4 to 16, what will you need to do to that top number? Have a go. Okay, I hope you spotted that because 4 times by 4 is 16, you've also got to times the numerator by 4. So 2 over 4 becomes 8 over 16. 3 over 4 becomes 12 over 16. And 4 over 4 becomes 16 over 16, which is also equivalent to 1 whole, because our numerator and our denominator are exactly the same. So that is actually 1 whole. Well done, guys. Okay, Eva uses the same approach to find equivalent fractions for these fractions. However, how will her method change? Have a look at this first one here. We've got 4 over 12 and over 3. Now before, we were able to find out the missing number by using our multiplication. Now this time, we need to go the other way. So this time, we need to go the other way. And what is the inverse of multiplication? Well, that, my friends, is division. So what did we divide by 12 to get to 3? How did we get from 12 to 3? We had to divide by 4. So if we divided our 12 by 4 and got 3, what do we need to do with our 4? We also need to divide it by 4. So what's 4 divided by 4? Nice and easy. You should be shouting this at me. It is 1. Okay, pause me here. Have a go at 6 over 12 becomes over 4. And 6 over 12 becomes over 2. Remember, whatever we had to do to the denominator, we have to do exactly the same to the numerator. Well done, guys. Pause me and have a go. Bing! Here are my answers. Have you got the same? Did you spot that it was dividing it by 3 here and then dividing it by 6? Now, I've made a marvellous mistake. Can you spot it? What is my marvellous mistake? Yes, I've done 6 divided by 6, but I've got myself in a muddle. And I've put 6, which becomes an improper or top-heavy fraction, and it is not equivalent. So what should my answer be here? What have you guys got? Let me get my big red pen here to cross out my marvellous mistake. What should it be? 6 divided by 6 is actually, yep, it is 1. So it's equivalent to 1 over 2 or 1/2. And we can see that because 6 is actually half of 12. Well done if you managed to work those ones out, and if you managed to spot that we can actually still use our times knowledge and go in the other way. Well done, guys. Let's head over to the next one. Okay, now it's your turn. Have a go at these equivalent fractions. Can you fill out these missing blocks? And then after you've done that, can you write at least 3 equivalent fractions to these numbers? Which means you can have any equivalent fractions, but you get to decide how you're going to find them. Now, top tip, remember, whatever you do to your denominator, you must do to your numerator and vice versa. Okay, pause me and have a go. And then in 3, 2, 1, I'm going to show you the answers. How did you do, guys? Have a look at the reasoning and problem solving on the website, and remember to use a fraction rule to help you.